I'm Madhumita. We are presenting our project on Botnet detection system using Raspberry Pi 3. This project comes under network security, embedded systems and IoT. Our goal is to detect suspicious activity in IoT networks using a low-cost device like Raspberry Pi. This project also focuses on improving visibility in small-scale networks. It is designed to be simple, affordable and practical for real-world usage. What is botnet? A botnet is a group of compromised devices controlled remotely by an attacker. These devices can be an IoT device like cameras, routers, smart TVs, and sensors. A famous example is the Mirai botnet attack in 2016, which disrupted large parts of the internet. Botnets are mainly used for DDoS attacks, data theft, and spreading malwares. This highlights the importance of securing even small IoT devices. Why network security matters? Today, everything is connected through IoT. Every connected device becomes a potential entry point for attackers. Currently, billions of IoT devices are active worldwide and attacks have increased significantly. As the number of devices increases, the attack surface also grows rapidly. Without proper security, even a single weak device can compromise the entire network. Let me explain our problem statement. The main problems we identified are: first, most of the IoT devices have weak security like default passwords and open ports. Secondly, mobile hotspots isolate devices so scanning becomes difficult. Third, there is no proper monitoring system so attacks go unnoticed. This creates a major gap in detecting real-time threats. Our objective is to detect these threats and improve IoT security awareness. Our project objectives. Our system focuses on mainly four objectives: device discovery using ARP scanning, port scanning to find open ports, anomaly detection to identify suspicious behavior, and building a low cost intrusion detection using Raspberry Pi. The system aims to provide continuous monitoring of the network. It also helps in identifying unauthorized devices quickly. System components. The system consists of both hardware and software. Hardware includes the Raspberry Pi 3B+, software includes Python, Scapy for packet analysis, socket programming for scanning, and host APD with DNS mask for network setup. These tools work together to perform scanning and monitoring tasks. The design is lightweight so it can run efficiently on low power devices.
Now I'm going to explain how the system works. The system works in four steps. First, ARP scan to detect devices. Second, port scan to check open ports. Third, login and alert generation. Finally, intrusion detection based on collected data. Each step feeds into the next, creating a continuous monitoring system. This diagram shows the internal workflow of our system. It includes device discovery, scanning modules, logging system, and detection engine. All components are connected to provide a real-time monitoring and analysis. When using a mobile hotspot, client isolation is enabled. This means devices cannot communicate with each other, so the Raspberry Pi cannot detect other devices. As a result, the network scanner becomes ineffective. In a router-based network, all devices are in the same subnet. This allows the Raspberry Pi to detect devices, scan ports, and analyze traffic. So the system works properly in this setup. The best solution is using Raspberry Pi as a hotspot. Here all the devices connected directly to the Pi. There is no isolation, so full visibility is achieved. This time allowing real-time intrusion detection and monitoring. To conclude, mobile hotspot is ineffective, router is partially effective, and Pi as a hotspot is the best solution. For future work, we can add real-time alerts, web dashboards, advanced IDS tools like Smart, and machine learning for better detections. These are the references we use for our project, including research papers and online resources.
So, hello everyone, myself Logesh. Now I will demonstrate the simulation of our IoT bot detection using Cisco Packet Tracer. As you can see on the screen, we have a simple network setup. It consists of multiple end devices like a PC, laptop and smartphone, which represents IoT or user devices. All these devices are connected to a wireless router which acts as a central communication point in the network. On the right side, we have a server which represents our monitoring and detection system. In a real-world implementation, this will be our Raspberry Pi running the detection algorithm. In this simulation, all devices send their network traffic through the router to the server. The server continuously monitors this traffic, similar to how our real system captures packets using tools like TCP dump. Now let's understand the working. When normal traffic flows in the network, everything works smoothly without any alerts. However, if one of the devices behave abnormally, for example, sending too many packets or trying to access multiple destinations rapidly, maybe it's a botnet attack like DDoS or some kind of scanning attacks. At this point, the monitoring the system detects unusual traffic patterns based on predefined threshold and analysis. Once detected, the system can generate alert and identify the suspicious device. So this simulation helps us visualize how traffic flows in a network and how a centralized system can monitor and detect malicious activity. Even though Cisco Packet Tracer does not support full real-time machine learning implementation, it effectively demonstrates the network architecture of and detection concept of a project. In summary, this simulation represents how our real system operates at the network level to identify and respond to potential botnet attacks. First, I will send a normal packet from the PC to the server by making add a simple PDU server from the PC 0 to server 0. So by simulating it, so here we can see that the packet is delivered successfully. This represents a normal traffic network communication where devices send limited and expected traffic. So now we're going to be simulating a botnet attack. Now I will add a complex PDU with a periodic transmission. So now here the PC continuously sends packet to the server at a regular interval. So this behavior mimics a botnet attack where a compromised device floods the network with excessive traffic. Thank you.